Hello guys, welcome to my YouTube channel. So for this recording I'm going to talk about bounded below, bounded above and bounded. So let's consider the set S as our set. So we say set S is bounded below if there exists, so this is the notation of there exists a real number a real number m, small letter m, such that m is less than or equal to x for all x element of S. Okay, so let's consider this example. Um, this is our real line. This is our set S. This is our set S. This is our set S. So we're saying if there exists a real number m, okay, so let's say this is A, this is B, and x is and m is less than x, so all these uh, values here for x, sorry, for s, so here we say the number that is less than or equal to, so we are looking for a number here on this side. Okay, so the number that is less or equal to a, so this is a, so this is the number which is less than a, this is the number which is less than a, number less than a, so the number which we're saying the set S is bounded below if there exists a real number m such that m is less than x, so we're looking for a number which is here. So um, we then say the set is bounded below if there exists a number here in this part. Okay, so let's consider this example. Let's say S is equal to 1, 2, 3, 4. Okay, so S, we're having this 1 and 4, 1 and 4. So S is bounded below by 1. So S is bounded below by 1. Okay, S is bounded below by 1. Okay, so we say S is bounded below by 1. We can also say S is bounded by 0. The close real number here is 0 or 0.9. So we can say it's 0, 0.9 or 1. Okay, so since we have 1 here, so we can choose 1. Okay, since we have 1 in the set, so we can choose 1. Okay, so the 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 set is bounded below by 1. Okay, this is the second example. Let's say S is this open interval which is 0 and 1. Okay, sorry. Now S is, this is your 0, This is your 1. Okay. So S, we are having this is 0. We're having negatives here. So S is bounded below by what? By 0. So we say S is bounded below by 0. Okay, by 0. Then we say the set S is bounded above. So the set S is bounded above if there exists a real number M, capital letter M. Okay, let me just write it. So set S is bounded above if there exists a real number. If there exists a real number, capital letter M, such that the capital letter M is greater or equal to X. Okay, so let's say this is our set S. This is A, this is B. Okay, so now this is okay for all X is an element of S. Okay, for all. So now we are looking at this part. This part. There are so many bounds here, upper bounds. So we are looking at B and the number that is greater than B. Okay. So the upper bound here is B. This is the upper bound. So we say S is bounded above by B. Okay. Say S is bounded above by B. Okay. Let's also consider the example that I gave above, which is 1, 2, 3, 4. So for this one, the upper bound here is 4. So this is set S. So the upper bound here is 4. We say S is bounded above by 4. Okay. So then the other example, which was 0 and 1. So here, sorry, we have 0 and 1. So here there is 1 and there are many upper bounds, but we will consider 1. So we say S is bounded above by 1. Okay, this is the bounded above. So we say the set is bounded up. We say the set is bounded when it is bounded below and is bounded above. Okay, the same time, but concurrently. So now we say a set S is bounded if it has both bounded below and bounded above. So, in other words, we say there exist real numbers m, small letter m, and capital letter M, such that m is less than or equal to x and x is less than or equal to m. Okay, so this is our set S. So this is our set S. These are the values of x. Okay, all the values of x here. Now there exists a number which is small letter m. Small letter m is small letter m. Okay, let me not write x. Small letter m is less or equal to a, and capital letter, okay, b is less or equal to capital letter M. So now we say the set is bounded if there exists the small letter m which is less than or equal to a, and the capital letter M which is less than or equal to e. Okay, so don't be confused with these a and b's. So these here are all the values of x. Okay, this part, um, so for all x is the element of S. So this part we're saying for all elements of x are sorry, for all x is the element of S. So here we have what the elements of S which are represented here by x. So A is the element of S, B is the element of S. A is the element, A and B are elements of S. Okay, this is the same thing, but X represent all these values here, all these values. Okay, now this A and B, we're talking about the individual now. So this is the lower bound and the upper bound. So they are this set is bounded. It's bounded below and it's bounded above. Now we call this set as a bounded set. So this set is bounded. Okay, this set S is bounded. So the set S is bounded. So here we say, so we know this natural numbers. The set of natural numbers is infinite. Okay, so the set of natural numbers is an infinite set. So 1, 2, 3, and it continues to infinite. So sorry, this this set is only bounded above, sorry, below. It's only bounded below. So the set is bounded below by 1, and 1 is the element of the natural numbers. It's not bounded above because we don't have a number here. So A is bounded below and above by 1 and 3 respectively. So 1 and 3 are elements of A. And B is bounded below and above, so it's bounded by 0 and 1, and 0 and 1 are the elements of B. So C is bounded by 0 and 1, but 0 and 1 are not the elements of C. So that's all for this video. If you have comments, so you can leave your comment. Please like if you find this video interesting or helpful. Thank you.